Exploring pi is like exploring the universe. Calculating pi in context. Key figure Archimedes, circa 287 to circa 212 BC. Field. Number theory. Before. Circa 1650 BC. The Rhind Papyrus, written by Middle Kingdom Egyptian scribes as a mathematics guide, includes estimates of the value of pi. After. 5th century. In China, Zhu Chongxi calculates pi to 7 decimal places. 1671, Scottish mathematician James Gregory develops the arctangent method for computing pi. Gottfried Leibniz makes the same discovery in Germany 3 years later. 2019, in Japan, Emma Haruka Iwao uses a cloud computing service to calculate pi to more than 31 trillion decimal places. The fact that pi, the ratio of the circumference of a circle to its diameter, roughly given as 3.141, cannot be expressed exactly as a decimal no matter how many decimal places are calculated, has fascinated mathematicians for centuries. Welsh mathematician William Jones was the first to use the Greek letter pi to represent the number in 1706, but it's important for calculating the circumference and area of a circle and the volume of a sphere has been understood for millennia. Pi is not merely the ubiquitous factor in high school geometry problems, it is stitched across the whole tapestry of mathematics. Robert Knigle, American science writer. Ancient texts. Determining pi's exact value is not straightforward in the quest to find pi's decimal representation to as many places as possible. Two of the earliest estimates for pi are given in the ancient Egyptian documents known as the Rhind and Moscow Papyri. The Rhind Papyrus, thought to have been intended for trainee scribes, describes how to calculate the volumes of cylinders and pyramids and also the area of a circle. The method used to find the area of a circle was to find the area of a square with sides that are 8/9 of the circle's diameter. Using this method implies that pi is approximately 3.1605 calculated to 4 decimal places, which is just 0.6% greater than the most accurate known value of pi. In ancient Babylon, the area of a circle was found by multiplying the square of the circumference by 1/12, implying that pi was the value of 3. This value appears in the Bible, the first book of Kings, chapter 7, verse 23, and he made the sea cast bronze 10 cubits from one brim to the other. It was completely round, its height was 5 cubits, and the line of 30 cubits measured in circumference. In circa 250 BC, the Greek scholar Archimedes developed an algorithm for determining the value of pi based on constructing regular polygons that exactly fit within or enclosed in a circle. He calculated upper and lower limits for pi by using Pythagoras' theorem that the area of a square of the hypotenuse, the side opposite the right angle, in a right angle triangle, is equal to the sum of the areas of the squares of the other two sides, to establish the relationship between the lengths of the sides and of regular polygons when the number of sides was doubled. This enabled him to extend his algorithm to 96-sided polygons. Determining the area of a circle using a polygon with many sides has been proposed to at least 200 years before Archimedes, but he was the first person to consider polygons that were both inscribed and circumscribed. Archimedes. Born in circa 287 BC in Syracuse, Sicily, the Greek polymath Archimedes excelled as a mathematician and engineer and is also remembered for his eureka moment when he realized that the volume of water displaced by an object is equal to the volume of that object. Among his claimed inventions is the Archimedes screw, a revolving screw-shaped blade in a cylinder which pushes water up a gradient. In mathematics, he used practical approaches to establish the ratio of the volumes of a cylinder, sphere, and cone with the same maximum radius and height to be 3:2:1. Many consider Archimedes as a pioneer of calculus, which was not developed until the 1600s. It was killed by a Roman soldier during the siege of Syracuse in 212 BC, despite orders that his life was to be spared. Squaring the circle. Another method for estimating pi, squaring the circle was a popular challenge for mathematicians in ancient Greece. It involved constructing a square with the same area as a given circle. Using only a pair of compasses and a straight edge, the Greeks would superimpose a square in a circle and then use their knowledge of the area of a square to approximate the area of a circle. The Greeks weren't successful with this method, and in the 1800s, squaring a circle was proved to be impossible due to pi's irrational nature. This is why attempts to achieve an impossible task are sometimes known as, quote, squaring the circle, unquote. Another way mathematicians have attempted to square the circle is to slice it into sections and then rearrange them into a rectangular shape. The area of the rectangle is r times half times 2 pi r, which is r radius times pi radius to squared, where r is the radius of the circle and 2 pi r is its diameter. The area of a circle is also pi r squared. The smaller the segment is used, the closer the shape is to a rectangle. The works of Archimedes are without exception works of mathematical exposition. Thomas L. Heath, historian and mathematician. The quest spreads. More than 300 years after the death of Archimedes, Ptolemy, circa 100 to 170 CE, determined pi to be 3 by 8 by 30, base 60, that is 3 to the 8 8/60ths to the 3600ths, 3.14.6, which is just 0.007% greater than the closest known value of pi. In China, 3 was often used as the value of pi until the square root of 10 became common from the 2nd century. The latter is 2.1% greater than the pi. In the 3rd century, Wang Faust stated that a circle with a circumference of 142 had a diameter of 45, that is 142 divided by 45, which is just 3.15, just 1.4% more than pi, while Liu Hui used a 3,072-sided polygon to estimate pi as 3.1416. In the 5th century, Zhu Zhongji and his son used a 24,576-sided polygon to calculate it as 355 over 113, which is 3.14159292. A level of accuracy to 7 decimal places not achieved in Europe until the 1500s. In India, the mathematician astronomer Aryabhata included a method for obtaining pi in his Aryabhatian astronomical treatise of 499. Add 4 to 100, multiply by 8, then add 62,000. By this rule, the calculation of the circumference of a circle and diameter of 20,000 can be approached. This works out as 8 by 100 plus 4 plus 62,000 divided by 20,000. 62,832 divided by 20,000 equals 3.1416. Brahmagupta, circa 598 to 668 CE, derived square root approximations of pi using regular polygons with 12, 24, 48, and 96 sides. Squares of 9.65, squares of 9.81, squares of 9.86, and squares of 9.87, respectively. Having established that pi squared is 9.8696 to 4 decimal places, he simplified these calculations to pi, the root of 10, square root of 10. And during the 9th century, Arab mathematician Al-Khwarizmi used 3 1/7 square root of 10 and 62,832 divided by 20,000 as values for pi, attributing the first value to Greece and the other 2 to India. English cleric Adelard of Bath translated Al-Khwarizmi's work in the 12th century, renewing an interest in the search for pi in Europe. In 1220, Leonardo Pisa, aka Fibonacci, who popularized Hindu Arabic numerals in his book Liber Abaci, the Book of Calculation, 1202, computed it to be 864 over 275 equals 3.141, a small improvement in Archimedes' approximation, but not as accurate as the calculations of Ptolemy, Zhu Zhongji, or Aryabhata. 2 centuries later, Italian polymath Leonardo da Vinci proposed making a rectangle whose length was the same as a circle's circumference and whose height was half its radius to determine the area of a circle. Archimedes' method used in ancient Greece for calculating pi was still being used in the late 16th century. In 1579, French mathematician François Viète used 393 regular polygons, each with 216 sides, to calculate pi to 10 decimal places. In 1593, Flemish mathematician Adriaan van Romanus used a polygon with 230 sides to compute pi to 17 decimal places. 13 years later, German-Dutch professor of mathematics Ludolf van Soilen calculated pi to 35 decimal places. The development of arctangent series by Scottish astronomer, mathematician James Gregory in 1671 and independently by Gottfried Leibniz in 1674 provided a new approach to finding pi. An arctangent series is a way of determining the angles in a triangle from knowledge of the length of its sides, and it involves radian measure, which a full turn is 2 pi radians, equivalent to 360. Unfortunately, hundreds of terms are needed to compute pi to even a few decimal places used in this series. Many mathematicians attempted to find more efficient methods to calculate pi, including using arcton, including Leonard Euler in the 1700s. Then, in 1841, British mathematician William Rutherford computed 208 digits of pi using the arcton series. The advent of calculators and electronic computers in the 1900s made finding the digits of pi much easier. In 1949, 2,037 digits of pi were calculated in 70 hours. 4 years later, it took around 13 minutes to compute 3,089 digits. In 1961, American mathematicians Daniel Shanks and John Wrench used arcton series to compute 100,625 digits in under 8 hours. In 1973, French mathematician Jean Gouliard and Martin Boyer achieved 1 million decimal places, and in 1989, 1 billion decimal places were computed by Ukrainian-American brothers David and Gregory Chudnovsky. In 2016, Peter Trobe, a Swiss particle physicist, used the Y-Cruncher software to calculate pi to 22.4 trillion digits. A new world record was set when computer scientist Emma Haruka Iwao calculated pi to more than 31 trillion decimal places in March 2019. There's no end with pi. I would love to try with more digits. Emma Haruka Iwao, Japanese computer scientist. Applying pi. Space scientists constantly use pi in their calculations. For example, the length of orbits at different altitudes above a planet's surface can be worked out by using the basic principle that if the diameter of a circle is known and its circumference can be calculated by multiplying by pi. In 2015, NASA scientists applied this method to compute the time it took the spacecraft Dawn to orbit Ceres, a dwarf planet in the asteroid belt between Mars and Jupiter. When scientists at NASA's Jet Propulsion Laboratory in California wanted to know how much hydrogen might be available beneath the surface of Europa, one of Jupiter's moons, they estimated the hydrogen produced in a given unit area by first calculating Europa's surface area, which is 4 pi r squared, as it is for any sphere. Since they knew Europa's radius, calculating its surface area was easy. It is also possible to work out the distance traveled during one rotation of Earth by a person standing at a point on the surface using pi, providing the latitude of the person's position is known.